Hello, this is Mr. Huber. In this lesson, we're going to continue working on binomial radical expressions, this time multiplying and dividing them. So let's look at multiplying. Okay, when we're multiplying binomial radical expressions, we're going to use the distributive property and FOIL just like we would if there weren't radicals in there at all. So we can see in this first example, if we distribute the 4 into the parentheses, right? That's our F and our O, the first and then the outer. So 4 times 5 is 20. And then 4 times 4 root 2 is 16 square root of 2. Okay? We're going to multiply the 4 times the 5 and get 20. And then the 4 times the 4 root 2. The 4 times 4 gives us 16. And then we have the root 2. And now we're going to distribute the 2 root 2 into the parentheses. So 2 square root of 2 times 5 is 10 square root of 2. And 2 square root of 2 times 4 square root of 2. Let's write that over here on the side. If we have 2 square root of 2 times 4 square root of 2, the 2 times 4, right? The 4 times 2 is going to give me 8. And the square root of 2 times square root of 2 is 2. So that's going to be 16. So we're going to have plus 16. Right? Okay. We're going to get 2 times 4 is 8 times, when we multiply the square root of 2 times itself, we get 2. So 8 times 2 gives us the 16. And now we can simplify this because we can add the like terms. The 20 and the 16 is 36. And then we're going to have plus 26 square root of 2. And that would be our final answer. After you FOIL, then you want to look and see if there's any like terms you might be able to combine there. See another example here. We're going to use FOIL again. So we'll do the square root of 7 times the square root of 7. That's 7. Square root of 7 times 5 is 5 square root of 7. Then we have negative 3 times the square root of 7 is negative 3 root 7. And negative 3 times 5 is negative 15. And now I can combine the 7 and the minus 15. That's negative 8. And the 5 root 7 minus 3 root 7 is a positive 2 square root of 7. And that'd be our final answer. So you're foiling, just like you would if there weren't radicals there. We just have to make sure we know how to work with the radicals in terms of when we multiply them by themselves and we have the like terms there at the end that we can add or subtract. Right. Before we see some other examples here, a little football, they're known as soccer in our country here. What country won the first soccer World Cup championship in 1930? Okay, so the first ever soccer World Cup was held in 1930. The country that won it was also the host country. You see their flag there. You may not know which country that is still. That is Uruguay, or pronounced Uruguay, more locally there. They won the first World Cup final held in Uruguay in 1930 in front of about 93,000 spectators. So a large crowd there to see them defeat Argentina 4-2. So Uruguay winning the first ever soccer World Cup in 1930. Okay, let's look at some other things with foiling here. In foiling and multiplying something called conjugates. Right? These are examples of conjugates where we have two binomials that are the same except for the plus and the minus. Right? Here, two binomials that are exactly the same terms, except one is a plus and one's a minus between them. It doesn't matter which one's the plus or the minus, okay? As long as they're different. Here a plus and a minus 5, here a minus square root of 3 and plus square root of 3. These are called conjugates, as are these. So let's look at what happens when we multiply conjugates. Let's do one without the radicals. Let's just do x plus 5 and x minus 5. And you may recall this is something called a difference of squares when we multiply it out. So let's see when we do x times x, we get x squared. X times 5 is minus 5x. Then we're going to have 5 times x is plus 5x. And 5 times negative 5 is negative 25. So when we simplify this, these two terms here in the middle cancel each other out. Negative 5x plus 5x cancels out, and we end up with x squared minus 25. If we FOIL the second one, we get 8 times 8 is 64. 8 times root 3 is a plus 8 square root of 3. And then we're going to do negative square root of 3 times 8 is negative 8 square root of 3. And negative square root of 3 times negative square root of 3 is negative 3. Right? So we see when these two middle terms cancel each other out, the plus 8 square root of 3 and minus 8 square root of 3 is 0. 64 minus 3 is 61. Okay? So the key here is when we multiply these two conjugates and FOIL them, these middle terms cancel, and we end up with just x times x, which is x squared, and 5 times 5, which is 25, and it's going to be a minus there in between them. Over here, 8 times 8 is the 64. The middle terms cancel, and negative square root of 3 times negative square root of 3 is 3, and we have a minus. So it's 64 minus 3. We multiply the 8 times 8, the first terms, we multiply the two last terms, and then subtract them. We multiply the two first terms, x times x, we multiply the two last terms, and then we subtract them. So we can use that as a little bit of a shortcut when we multiply conjugates. They will cancel those radicals out when we see them. Okay? So we just did that 8 minus the square root of 3 times 8 plus the square root of 3. Okay? In the second example, you can try that other one again if you want. Make sure you're understanding here before we do the next example. But when we do this, all we're going to have to do is multiply the 3 root 6 times 3 root 6. That's 9 times 6. 3 times 3 is 9. Square root of 6 times square root of 6 is 6. So 9 times 6, that's 54. And then we do 10 times 10 is 100, and it's minus 100. So 54 minus 100, that would be negative 46. That's our answer. We don't have to worry about those middle terms. They're going to cancel each other out. So this works when it's conjugates. Same binomial, one's a plus, one's a minus. And then we're going to get it simplified down here to negative 46. So understand how to work with those conjugates. If you do FOIL all the way, you should get middle terms that cancel, but you can really help simplify things for yourself. And when you see that word, that conjugates, it helps simplify things when there's radical expressions. So knowing that term is good as well.